Ohm's law.
Give today's heading. Ohm's law. Ohm's law.
So
Okay.
OHM.
So
Yeah. Ohm's law.
OHM.
OHM. HH. Ohm's law. Okay. Write down the statement of Ohm's law, right? The current flowing through a conductor. Write down the statement. The current flowing through a conductor. The current flowing through a conductor is directly proportional. Is directly proportional to the potential difference. Directly proportional to the potential difference. Potential difference you can add in short PD. Potential difference under bracket you write voltage. Voltage applied across its ends. Applied.
Sir. Yes, sir.
Potential difference under bracket voltage applied across its ends. Across its
Ends.
Provided ends across its ends, provided that the temperature and the other physical conditions are constant. Then, therefore, you write,
We do this in chemistry also, no?
Ohm's law you have in chemistry also. Huh? It is applicable for all kinds of electrical circuits.
Class 9.
And therefore, that I is proportional to V.
Physics, sir.
Right like this. I means current, V means voltage or potential difference. Right now, therefore, I is directly proportional to the voltage. What is the meaning of this? More the voltage, more the current. Less the voltage, less the current. When you increase voltage, current will increase. When you decrease voltage, current will decrease. No voltage, no current. We continue further, we write equal to V by R, where R is constant, 1 by R is constant, therefore V value will become IR, mentioned as this. This is a mathematical form of Ohm's law, V equal to IR. This formula we get from Ohm's law, or I equal to V by R. Right here, where R is resistance of the conductor, where R is known as resistance of the conductor. R is resistance of the conductor with the SI unit, Ohm, and we denote by this sign, this symbol. With the SI unit, this much. This symbol is read as omega. With the SI unit, Ohm, bracket omega. Omega you write like this way you write. This symbol is read as omega, which represents Ohm. Done.
Resistance SI unit is this.
Yeah, SI unit of R. SI unit of R is resistance. SI unit is ohm. OHM. Okay.
Sir, resistance
Denoted by
SI
the
unit
symbol.
is, sir, resistance omega, no, sir, then what the,
Huh?
then, sir, last time also, sir, something you gave for the value of this,
Value of
resistance, sir, SI unit.
SI unit. When did I give?
No, we didn't.
No, nothing, sir.
No, we
No,
didn't.
sir, you didn't give.
I didn't give. Okay, now write down. Right below this definition of 1 ohm. Question is define 1 ohm resistance. Write down definition of 1 ohm. Definition
Sir,
of 1 ohm.
definition.
1 ohm. 1 ohm. Define 1 ohm like this. 1 ohm. Definition of 1 ohm. Right. It is the resistance. It is the resistance offered. It is the resistance offered by a conductor. It is the resistance offered by a conductor when it is the resistance offered by a conductor when 1 ampere current when 1 ampere current when 1 ampere current flows when 1 ampere current flows through a PD of flows through a PD potential difference flows through a PD of 1 volt flows through a PD of 1 volt. Now here you are going to define 1 ohm. R value should come when. It is the resistance offered by a conductor when 1 ampere current flows through it by a PD of 1 volt. The idea is, the formula V equal to IR, current value I will take 1 ohm, 1 ampere, and the voltage value I will take 1 volt. R value will become 1. Then it is the resistance offered when 1 ampere current flows through a conductor by a voltage of 1 volt or by a PD of 1 volt. Okay. Now write down below this. Below this, give the next heading: conductance. 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 Below this, conductance. Conductance is denoted by the symbol G, capital G. Conductance. Conductance is denoted by the symbol capital G. Write about it, right? It is reciprocal of resistance. Write down. It is reciprocal. It is reciprocal of. It is reciprocal of resistance. This is conductance. Conductance is just a reciprocal of resistance. Write down. Therefore, G is equal to 1 by R. Conductance formula is 1 upon R, 1 upon resistance. And I equal to V by R or R is equal to V by I. Therefore, G will be equal to just opposite I by V. 1 by R or we connect I divided by V. We connect either this or this. I divided by V. Okay, now write down the SI unit of the SI unit of conductance is the SI unit of conductance is per ohm just divided by per ohm, or you can let it ohm to the power -1. Ohm to the power of -1, which we call ohm inverse. Inverse is power -1. We call it ohm inverse. 1 upon R unit is ohm. So 1 upon ohm will become power -1. This SI unit is per ohm or ohm inverse. Okay, I think you understood. Now write down below this limitation of Ohm's law. Limitation of Ohm's law. Give the heading limitation of Ohm's law. Right. Ohm's law is valid only. Ohm's law is valid. Ohm's law is valid only. Ohm's law is valid only when temperature is constant. When temperature is constant. When temperature is constant. Question may come, what is the validity of Ohm's law, or when the Ohm's law is valid? We say Ohm's law is valid only when temperature is constant. Or what is the limitation of Ohm's law? For that also we write this answer. Ohm's law is valid only when temperature is constant. When temperature fluctuates, Ohm's law will not be valid, will not be applicable then. Okay. Now give next heading. Yeah, you wanted to say something?
No, sir. It's only one hour.
Okay. Only one limitation. Now give next heading. You give now types of conductors. Types of conductors. Number one, ohmic. Ohmic conductors. And number two, non-ohmic. Non-ohmic. Non-ohmic conductors. Ohmic conductors and non-ohmic conductors. Okay. What are ohmic conductors? What are non-ohmic conductors? Let me tell you. The conductors which obey Ohm's law are called ohmic conductors. As simple as that. The conductors which follow or which obey Ohm's law are called ohmic conductors, and the conductors which does not obey or which do not obey Ohm's law are called non-ohmic. Okay, now write about ohmic conductors. First one is.
Is he a scientist? Who is Ohm?
Ohm was a scientist. Ohm was a
From
scientist.
India. Sir, from India.
Yeah, from your university. Okay, from your village. Okay, write down this one. Ohmic conductors definition is right. The conductors which obey Ohm's law. The conductors which obey Ohm's law are called ohmic or linear conductor or linear 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 conductors. So that for example metals. All metals obey Ohm's law, so they are all an example of ohmic conductors. All kind of metals, but the metal have to be conductors, obey Ohm's law. Now write down same line. The VI graph, the VI graph for ohmic conductors. The VI graph for ohmic conductors can be drawn as follows. The VI graph for ohmic conductors can be drawn as follows. Okay. We draw voltage current graph. A rough graph will draw. We don't need a graph paper for it. First is V, so V will come here. Next is I, so I will come here. So they are directly proportional. We know that I is directly proportional to V. The graph will come in the form of a straight line like this. In the form of straight line like this. This way it will come. It can start from anywhere. It can start from this point, or it can start from here, or here, from here. But it will be a straight line like this, going upward, going upward. So this is the graph for ohmic conductors. That is why this conductor is also known as linear. Linear is straight line conductor. The graph is represented by a straight line. Okay, we find slope of the graph. Write down slope. Slope of VI graph. Slope of VI graph equal to. You know, slope, I think class 9 I used to do that, and even in the beginning I taught this. Slope means voltage by this axis divided by this axis. When you divide V by I, what are you going to get? Any idea? V by
Slope.
I gives you what?
Slope. Slope.
No,
V
that gives
I
slope.
coordinates divided by I coordinates will get slope.
You get the slope, but what does it represent? What does the slope signify?
At how much degree it is bent?
Angle.
Was it?
You got the formula, Ohm's law give you the formula V equal to IR. This is the formula you get now. V equal to I, V by I. What answer do you get now? V by I, when you divide, what answer are you going to get?
Resistance.
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 That only. Slope of VI graph is equal to resistance. Resistance. Why should we find slope? We find slope in order to find the resistance of the conductor. Resistance of the conductor. Or what does the slope of VI graph represent? We say it represents resistance. Or it gives the value of resistance. More the slope, more the resistance. Less the slope, less the resistance. If the line is like this, lesser slope. If the line is more steep, slope is more. More inclination, more angle, that is slope is more, that is the resistance is more. What does the slope of VI graph signify or represent? We say it represents slope, or it gives the value of slope. Okay. But if it is just opposite, if it is I taken here and out here V is taken, by chance, you see the graph shown in the question paper. If it is I out here and if it is V, and when you find the slope, what will you get now? Tell me.
G. We get G. G.
Conductance.
You will get G. Conductance, yes, very good. Very good. That means what does the slope of IV graph represent? We say the slope of IV graph represents conductance. Conductance. Yes. Or reciprocal of resistance you can say, or you can say conductance. Better word is conductance. So you need to read the graph carefully. I mean, see the graph carefully, what they have given, how they have labeled their axis. If the axis is VI, then we say VI graph, voltage here and current here. If IV graph, it will be conductance. Understood? What are the example of ohmic conductors? Tell me, what are the example of ohmic conductors? What are the examples?
Metal is like
Non-metal.
Metals, I said you have written there also, and you are saying non-metal. What happens in our world? Metals. Suppose the graph starts like this. Is it ohmic conductor or non-ohmic conductor? Tell me. Is it ohmic or non-ohmic?
Ohmic. Ohmic.
Ohmic will straight line going upward. That is directly proportional. It is directly proportional. Either V here or I here. It is also ohmic. It can start from anywhere, any point. Even it can start this way also. It can start in this manner also. Like this also it can start. Anywhere it can start, but it is ohmic. Okay. Now give next heading now, non-ohmic conductors. Non-ohmic. Non-ohmic. Non-ohmic conductor. No, what is non-ohmic conductors? Tell me what are non-ohmic conductors?
Which do not
Or
follow
which
Ohm's
does
law.
not
Which do
follow
not
the
which do
Ohm's
not
law.
obey the
Which does not
Ohmic's
follow
law.
the
Right. The
Ohm's law.
conductors, right on. Yes. Yes. The conductors which do not obey Ohm's law. Right on. The conductors which do not obey Ohm's law. The conductors which do not obey Ohm's law are called non-ohmic conductors. Are called non-ohmic conductors. Are called non-ohmic conductors. Non-ohmic conductors or non-linear conductors or non-linear or non-linear conductors. Non-linear conductors. That for example, write down for example, filament of a bulb. For example, filament, F-I-L-A, filament of a bulb, B-U-L-B, filament of a bulb, comma, write down.
Killing of bulb
Bulb, you don't know. Bulb we are using at home. You don't know the spelling of
So the
bulb.
glass part. So the glass part.
is got.
What is that?
So I said bulb.
Electric bulb, you don't know. Come on.
All foolish boys.
B-U-L-B, bulb.
Yeah, we use bulb.
Sound problem.
Bulb, right. Semiconductors. Semiconductors.
Semi.
Semiconductors. Comma. Transistors. Comma, diode, etc. Transistors, comma, diode. Transistor is not a radio set, okay? Transistor is a small electronic.
So what did you say after transistors?
Sir, your voice is cracking.
Sure, you're lagging. So you're frozen.
So you are.
Diode.
So you're lagging.
D-I-O-D-E, diode. Okay?
Yes, sir.
Diode, etc. Now write down the VI graph, the voltage current, the VI graph for non-ohmic conductors. The VI graph for non-ohmic conductors is as follows. The VI graph for non-ohmic conductors, V here and I here. The VI graph will not be a straight line, definitely. So it will be coming in the form of a curve, like this kind of curve. Any kind of curve will come, any shape. Like this, it can come. You can draw even like this. This way also it can come. Voltage, current. It can come any kind of curve, like this. This
Sir.
way, any kind of curve. Yes. Yeah, tell
So
me.
from any point the
Yeah.
any point the curve
From
is
anywhere it can start.
ma-
Yes. It can start from anywhere, but it will not be a straight line. That is why it is called non-linear conductors. Non-linear. It can begin from anywhere, but it will be in the form of a curve. It won't be a straight line. Remember it. That is why it is termed as what? Non-ohmic. And its slope is not constant. Slope is varies, no, because it is the line is variable. No, this line is a curved line. The slope varies. So it does not give you a fixed slope, rather slope of the graph at point determines the value of its resistance at that point because the resistance is varying here. That is why you say slope of this graph, slope of VI graph for non-ohmic conductor determines dynamic resistance. Dynamic is variable, dynamic resistance. It will not give a static resistance or constant resistance, rather it will give a dynamic resistance, dynamic. Probably it is difficult for you all to find the slope because that is done in the higher classes. Oh. At a particular point, what is the slope and all that you do later on. But just have a knowledge about it that the slope of VI graph of non-ohmic conductor is not constant. It is variable. It gives a dynamic resistance, dynamic. Done? Finish?
Yes, sir.
You
Yes,
finish?
sir.
Okay. All right.
So what did you write? Slope equals what?
Dynamic
Slope equals
resistance.
dynamic.
Slope is equal to dynamic. Dynamic means variable. Movable. Dynamic means not fixed, variable. Okay. Now, next heading you give third one. Right about third one. Right? Superconductors. 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 Any idea? Boys, do you have any idea about superconductors? What are
Which follow
superconductors?
both non-ohmic and ohmic conductors.
Very strong.
No.
Very strong. Ultimate.
Conductors which are strong.
So it can conduct very high
Legendary.
current. It can
Very
with
high
the
current. Who said it?
we can conduct
Outer
very high level of current.
Okay, which can conduct very high level of current.
Next level.
Why it will?
So like
Why it
so
will
like that.
wait. Why will it carry a very high level of current? Because it offers zero resistance. Its resistance is zero. The conductors
So that's possible.
with zero resistance are called superconductors. You say that. Write on the substance. Can write down the definition, right? The substance under bracket you can write conductors. Substance or conductors, you can say any. The substance under bracketed conductors
The conduct
with zero resistance. With zero resistance. With zero resistance is called. With zero resistance is called a superconductor. It's called a superconductor. Called a superconductor. Full stop. Right on same line. Metals like
Metal.
metals like lead, mercury, metals like mercury,
copper.
etc. No, not copper. These are the metals. Okay. Metals like lead,
Why
mercury,
not copper?
etc.
So
Sir,
Wait. Lead, mercury, tin, etc. Become conductors.
we are lagging.
So you are like
Sir, can you please repeat?
Become
Vicky,
superconductors
Yes, we are
Please
lagging.
repeat once more.
like
the
lead,
study from etc.
tin, etc. I've written
So you're lagging.
metals like
so we can
lead,
hear you,
mercury,
bro.
tin, etc. Become superconductors. Become superconductors.
You are lagging.
Yeah.
What
Right?
is wrong with you?
Yeah. Metals like lead, mercury, tin, etc. Superconductors. Superconductors
So become or
So
at a
are
very low temperature.
So your Wi-Fi is not working.
Okay,
so you
are
are
Sir,
these
lagging too much,
superconductors?
sir.
So you are like
So you are lagging. Hello.
Sir,
so
please
you're
Connection
repeat.
lagging.
is there.
So can
I
you
think the connection is
answer
there.
etc. what you said?
Sir, it's
So beg your
fluctuating,
pardon.
sir, the connection.
so can you please
So
write
can
on
you
the
repeat
board?
what you said after etc.
Yes, sir. Please do.
Sir, sir, you're frozen.
See,
Hello, sir.
frozen.
Sir, are we audible?
You are frozen.
Sitting alone.
So, but where is the dress?
Frozen part 2.
Let it go.
Yeah, is it clear now?
It's Ambo.
Sir,
Metal
repeat
slash
once
lead
more.
mercury. Okay, once again I'm repeating. Please listen quietly and carefully. Metal slash lead, mercury, tin, etc. become superconductors at a very low temperature, under bracket at close to absolute zero or minus 273 degrees Celsius. Minus 273 degrees Celsius. Okay. You know, some metals are formed to become superconductors at a very low temperature. And what is the value of that temperature? Close to minus 273 degrees Celsius, like minus 270, minus 268 degrees Celsius, this kind of temperature. These metals are only formed to become superconductors, not all the metals. It is by nature. Somebody was asking copper. Copper does not become, never become superconductors. It is a good conductor, but not a superconductor. It offers some resistance, low resistance, but it offers some resistance. Though the value is low, but it offers. Silver is the best conductor, last time I told you. And silver offers the least value of resistance.
Bell rang.
Still here we are doing, okay. Still here. We are doing till here today.
Thank you, sir.
Thank you.
Okay?
Bye.
Okay, thank you. Thank you. Bye-bye.
Bye
Understand?
bye.
Bye, sir.
Take care.
Pick up the call.
Tata, sir.